Hi there, good afternoon, or should I say morning. This is Joshua from Group 1's Lesson 13, group collaboration. Since I can't seem to find anybody else who's in my group, Natalie's got things she's doing, and I can't find Tabitha, so I am going to be just recording what we went over through the inference of two means of independent sampling. And hopefully I'll get through the independent sampling just fine. Any questions, we will talk about it after class in chats. But basically, going over the homework, most of the homework was pretty straightforward. The preparation assignment was all about defining the meaning between what is the difference between a match pair data and independent samples. And then it had us go through boxes of a chart we had to finish, or we had to fill out. So part one would be, what is the difference between matched pair data and independent samples? And I wrote, with independent sampling, you have no pairing between two groups. So to explain it better, you have two groups that have sets of data in them. And the important thing to remember is there is knowing who was selected for group one tells you nothing about who will be selected for group two. That's the main difference between a match pair data and an independent sample data. Going on to part two, complete the chart below. You would say the hypothesis test for one mean. You would say the inference of two means of the paired data, and then the inference of two means of independent samples, which is what I just said a little earlier ago. For every single one of these, you have to assume that your data is simple random sampled from a population. For a sigma unknown, a distribution of sample means has to be normal. And that has to be the same for every single test that you do. The name of the distribution from which this test statistic is computed, I put as the answer all of them T distribution, because all of them do not rely on Z. The null hypothesis and possible alternative hypothesis. Your null for your sigma unknown is going to be mu is equal to mu naught. For paired data, your null hypothesis is going to be mu d is equal to 0. And finally, your null hypothesis will be mu1 is equal to mu2. Alternative hypothesis can be anything from equals, does not equal, or greater than or less than. The big difference is that for the inference of the independent samples, you're going to be computing two sets of data instead of the number 0 for the two paired data, or the sigma unknown, where you'd just be comparing the null to the sample average that you get. Moving on, the part where we had to do group presentation, what are the differences between the mean wages? We're designing a research study, and it's all about independent samples. So starting up with number one, what is a research question, or the research question of this data from this homework? What are the differences between the mean wages of BYU Idaho men and BYU Idaho women students? That is the question. Are there any differences? Do men earn more than women? Do women earn more than men? Based on gender, as far as our dollars per hour. So you state the null hypothesis. The null hypothesis is the wages of males is equal to the wages of females. Always have to assume that for a null hypothesis, there's no difference between both groups. For the alternative, I said the wages of men and the wages of women are not equal to each other. So that would be the alternative if we end up rejecting the null. Collect the data. Part 2. You'd have to describe the data collection process. Basically, what it says in the paragraph is that the students from one math department professor took a survey to determine hourly student wages based on their genders. I mean, that's the only thing it says, so I think that would be an answer. Step 3, to describe the data, I got the average wage of men, or X bar, is equal to 11.935. The standard deviation for men wages is 10.491, and the number of samples, sample size, N, is equal to 88. X bar for women, or the average mean for women wages, was 9.759. And standard deviation for the women's wages was 3.169. The actual number of women that were sampled was N equals 95 sample size women. I also wrote a bar graph here kind of showing about the women that were surveyed versus the men that were surveyed. There's a bit of a difference. You can kind of see that the women were a little more distributed throughout their results, whereas the men were more concentrated in one area. I mean, they did have a couple outliers, but they weren't. There was a little bit of problem with normality here. 4, step 4, you would make inferences. So what type of hypothesis test is appropriate for this one? Independent sample hypothesis. And what are the requirements met? Are the requirements meant for this test? Are they met? First of all, the sample size was large, which means that the normality test passes. It is a normal distribution because of a large sample size. We say it's approximately normal, so good enough. The problem is, though, I don't see anywhere in this assignment or in this paragraph that says a simple random sample was taken of the population. It says that they just took students from a survey. It doesn't say or from a class. Or they probably went to some classroom and said, "Here, take this," and they didn't do a whole SRS of anything. So I don't think there was an SRS done, a simple random sample, but I can speculate. Compute the test statistic. T equals -1.836. State the degrees of freedom. Degrees of freedom is 98.263. Compute the p-value and compare it to your alpha. Your p-value is 0.069, and comparing that to 0.05, the level of significance, p-value is greater than alpha. Make a decision. Do you reject or accept it? Do you reject or fail to reject the null hypothesis? The answer is you fail to reject the null hypothesis. And you thus say we have insufficient evidence to say that there is a difference between the wages of men and female students at BYU, Idaho. So rather than test a hypothesis, say you want to estimate the difference between female and male wages at 95% confidence level. Create a confidence interval and estimate this difference. Well, I got an interval of -4.529 on the low end, on the lower boundary, and on the higher boundary I got 0.76. Now, because 0 is inside that bracket between -4 and positive 0.17, this means that there is no difference. There's insufficient evidence using the confidence interval method to say that there is any difference between men and women wages, student-wise. So any kind of actions that you should take? Well, I suggest you probably take a real random sample of any kind of men and female students at BYU Idaho. You should probably go around and take a random sample from different sections of the school, or maybe you should go and have some kind of easier procedure of doing an SRS. Maybe that would give you a little more idea of what kind, if there is a difference. That, or you could accept these results, but I honestly don't see why you should. All right. I did do the homework, but because I'm alone, I don't think it would be wise to share my results on homework. But it was about the Prius, Toyota Prius results of 2005. And all you have to know is that the hypothesis test listed above would be more appropriate for the study would be independent sampling. The rest of these are the same that I just mentioned. All of them want you to state the p-value, measure the graphs and the histograms. I have them all here, but it's better discussed with a class or a group of members, but that is okay. Any questions or any kind of comments, feel free to ask. I will be taking this group collaboration tests. And hopefully next week we'll have some more people show up in our group. Thank you very much. I appreciate the time and the efforts, and we will come back again and re-meet about lesson 14. You'll end up having another lesson on statistics. Thank you very much. Have a nice day.